All right, your final related rates problem. Um, you're given a conical tank with vertex down. So it's a cone, maybe not drawn to scale, but you get it. 14 feet across and 8 feet deep. I'll just give you a hint here. Let's make this the radius of 7. It's nice we're given some information, but as you can preview with the volume, we're given radius and height, so we don't really care about the diameter. And then from top to bottom, if we can picture this as three-dimensional, it is 8 feet deep. Water is flowing into this at a rate of 24 cubic meters per minute. So we have a rate here given to us, and what's helpful is when it says cubic feet, that is a volume. So we actually have a rate for a volume. And so what this is, if it's a rate for volume, we were given dV dt based off of knowing that it's cubic feet. We want to find the rate of change of the depth of the water when it's 3 feet deep. So basically when it's like right here, we can picture there's like the bottom is all filled with water. We're like, oh, it's 3 feet deep. At that instant, right now it's empty. What happens? What is the exact rate of change of the depth? Well, the depth is basically saying a height. So I'm going to say dH dt. What you have to pay attention to. If you remember in class, we tried this first where we were like, oh, if we're given dV dt, let's just derive everything. We had to do the product rule because R and H are different variables, so we had to do first, if we split it here, first times the derivative of the second, and so forth with a product rule. We realize that we can actually just convert our radius into terms of height so that we could eliminate a variable completely from our problem and just solve this in terms of height. Now, hint, hint, I give you credit for watching this video because I'm going to give a little hint, hint. If you were in the word problem given information on how the radius is changing, you would not be able to eliminate radius from your problem. So you would actually have to just derive the volume problem as it is and do the product rule if you are given information about dr dt. Now, we weren't, so we actually are going to convert our radius. And if we think about this as a ratio of radius to height, we can see that it's actually 7 to 8. And if we want radius, we would just multiply both sides by height. So actually radius is 7/8 of our height. Knowing that information, now we can put that in for radius and completely eliminate radius from our problem and just solve in terms of height. So I'm going to pause the video. I encourage you to pause as well. Substitute that in for R and get what our new volume equation will be. Alright, so this is our new volume equation without needing our radius. So if we want to find a rate, you know what to do. Derive everything, see what you can plug in, and see if you can solve the rest of this without me. I'm going to pause the video and put the rest of this up there. I encourage you to do the same. Alright, here we go. This is how fast our height is changing at the instant the water level is at 3 feet high.